I had a whole intro planned, but then a cat decided to steal my chair. A couple weeks back, I showed off Supermicro's latest microcloud server, featuring AMD Epyc 4005 processors, along with Solidigm PCI Express 5.0 NVMe drives. Today, we're going to put it to work with a Proxmox CEPH Cluster. Spoiler alert, I might not go back to solo servers ever again. Welcome back to Craft Computing, everyone. As always, I'm Jeff. A quick recap, this is the Supermicro Microcloud, more specifically the AS3015MR-H10TNR. It's a 3U box with up to 10 of these individual compute nodes, each rocking an AMD Epyc 4565P 16-core Zen 5 CPU, along with 128GB of DDR5 ECC memory. With a base clock of 4.3 GHz and a boost speed of up to 5.7, this is an insane amount of power in such a small space. Not only that, but having it distributed into up to 10 separate nodes rather than one monolithic server means you get all the redundancy and replication you might need for your organization in one very tidy package. Today, we're going to set up a Proxmox CEPH cluster on the microcloud. This will let us pool some of the resources from each node together, allowing management of every node from a single web UI, and allowing for redundancy or even high availability in the services we plan on running. Thanks again to Supermicro for sending over the microcloud for this project, but they weren't the only ones to help out. Solidigm also sent over the storage for this build in the form of a dozen PS1010 7.68TB Gen5 U.2 NVMe drives. While the drives are Gen 5, unfortunately the microcloud interface is only 2 lanes instead of 4. Even still, a single disk is getting 7,500 megabytes per second reads and 6,300 megabyte per second writes. And 2 disks together in a server still means read speeds of over 15,000 megabytes per second. Unfortunately, I don't get to keep any of this hardware as it's going to be shipped back in a couple of weeks, but thanks again to Supermicro and Solidigm for letting me show it off. And while I still have my hands on it, let's build the fastest Proxmox cluster that I've ever put together. I've dabbled with some home lab configs here on the channel and built a couple small Proxmox clusters for clients over the last few years, but this is definitely one of the coolest hardware setups I think I've built with so far. We're going to be using 5 nodes, mainly because with 2 10 gigabit NICs per node, that's 10 ports, and is exactly how many ports that I had free in my 10 gigabit switch. If I were running this config in production, that is 5 nodes of AMD Epyc 4565P CPUs with a pair of Solidigm PS1010 7.68TB SSDs, I'd recommend going with at least 25 gigabit networking to ensure you're getting the most out of your hardware. Proxmox allows you to configure multiple networks in a cluster to handle different aspects, networking for your VMs, backend communication for storage and management, and the like. For today, we're going to be binding both 10 gigabit ports together into a single interface. This can cause some latency issues in production if you need all of your bandwidth for storage transfer between nodes, or you have a VM that needs all 10 gigabit to itself. But for today's demo, a shared 20 gigabit connection is going to work just fine. First off, each node needs to have the latest version of Proxmox installed, which at the time of filming is 8.4.5. Well, except for the fact that version 9 launched exactly 2 days ago from filming, but the instructions are identical between the 2 versions as far as I can tell. I'm installing Proxmox onto a single 500GB SSD in each node, leaving the 7.68TB drives alone for now. Like I mentioned, each node has a pair of 10 gigabit network ports, and I've got both connected to a 10 gigabit switch on a flat VLAN. Proxmox's network config by default sets up a network bridge and then assigns physical ports to communicate with that. When booting up Proxmox for the first time on these nodes, however, while my static IP address was configured for the bridge, it didn't automatically assign the physical network ports to the bridge interface. I had to manually configure each node to use the 10 gigabit NICs before I could access the web GUI. So with a physical keyboard, mouse, and monitor attached to each node, I had to type in IP address show and take note of the physical device names in each node. In my case, I wanted ENP1S0F0 and 0F1. Then I opened up etc, network, and interfaces, and then under the VM bridge 0, you'll see a line for the bridge ports. Enter your physical network interfaces here and save your changes. Once done, you will need to restart your network configuration. You can either reboot the node entirely or type in system control restart networking. With the networking all sorted, I will need to update each individual node before we add it to the cluster. Now, since I'm running Proxmox in a home lab, I don't bother paying for a subscription to the Proxmox Enterprise Update repo. In the web UI on each individual node, click on your server, go to Updates, and then Repositories, and then click on Add. You'll want to add the No Subscription repo. Then click on the Enterprise repo in the list and click on Disable. If running in a production environment, using the Enterprise repo is highly recommended, as it is a bit more stable and up-to-date, but does require a subscription from Proxmox. For home labs, or even small and medium business environments, the standard non-subscription route is usually enough. Make sure each server is up-to-date by running apt update and apt upgrade, and when updates are complete, I recommend rebooting each node, and then we can get started setting up our cluster. For a cluster setup in Proxmox, you want a minimum of 3 nodes, especially in our case when we're going to be sharing storage resources across the entire cluster. For a cluster to function, you need what's called a quorum. That is, all of the nodes must agree on which node is controlling the cluster. If a single node drops out, the remaining nodes will vote on which node becomes the master. If there are only 2 nodes remaining, each node will vote for the other, resulting in a tie. And if there is no master, there's no way to tell the nodes where the resources are at, and the whole thing breaks down. You'll also want to make sure the time and date on your nodes are all perfectly in sync, ideally by running a time server on your local network to avoid any issues. Ceph is extraordinarily picky about time, and desyncs in time can cause problems such as degraded performance and increased latency, instability, or even nodes and storage becoming completely unavailable. While you can set up a cluster completely in the web UI, I actually prefer to do it from the terminal, and believe it or not, it's actually a bit easier. The web UI requires copy and pasting secure keys between nodes and can be a bit confusing. In the terminal though, it's literally just a single command on the first node, along with a single command and the root password on all the other nodes that you want to join to it. In my setup, I have 5 nodes named MC1 through MC5. On MC1, I'm going to access the shell and type in pvecm create ceph-cluster. This will create a new cluster and add MC1 as a single node. Then I log into MC2 and type in pvecm add and then the IP address of MC1. This process takes about a minute and should result in MC2 being added to the cluster, along with both nodes being visible in the web UI. Repeat the pvecm add process on the rest of your nodes, and you should see them all appear in the web UI. Once you've got them all set up, we'll also need to enable Ceph monitoring on each node. In the web UI, click on each node, go to Ceph, and then click on Install when prompted. This should take less than a minute on each system. Once installed, go to each node, go to Ceph, and then Monitor, and click on Create. Once complete, each node should be able to monitor cluster health and real-time use, both for compute and for storage. Speaking of storage, what good is a compute cluster without clustered storage? Like I mentioned at the top of this video, in this cluster, each node is going to house a pair of Solidigm PS1010 Gen5 NVMe drives. The drives will be configured as one large storage pool, allowing for near instantaneous VM migrations between nodes, along with allowing for both redundancy and resilience in case of either drive or node failure. To set up the drive cluster, we'll have each node report what drives they are making available, and then set up our storage pool with those shared drives. Believe it or not, it's actually a very straightforward process that takes just a couple minutes to set up. A disk in Ceph is called an OSD, or an Object Storage Daemon. To pool drives together, we'll need to define the SSDs in each node as an OSD. Head to each node in the web UI, go to Ceph and then OSD, and click on Create OSD. Select the physical disk you want to make available to Ceph from the drop-down menu. Again, in my case, it's going to be the Solidigm PS1010s, and then click on Create. As you add OSDs, they should start showing up in the Ceph OSD tab, listing the node they're hosted on, the OSD type, and the available capacity. With all of the OSDs made available, it's time to create our Ceph storage pool. Head to one of your nodes and go to Ceph Pools, and then click on the Create button at the top of the screen. Give your storage pool a name. In my case, I'm going to name it MC Store. Similar to ZFS, Ceph is a block storage system that distributes data across multiple disks. The size field in the Ceph setup indicates how many copies of each block of data that you want to keep in the pool, while the minimum size indicates the minimum number of copies of each block that need to exist to keep the pool online. This is essentially the resiliency setup for your Ceph pool, and the default setting of 3 and 2 means that for every block of data you write to Ceph, you will have 3 individual copies spread across the pool, and the pool needs a minimum of 2 copies of your data to keep the Ceph pool online. There are a number of advantages to running Ceph in a cluster like this instead of a dedicated remote storage system, but also a couple downsides. While Ceph is extremely resilient, it doesn't do well when it comes to capacity. In the default 3.2 size configuration, you'll only wind up with 1/3 of your total drive capacity available to you. In my case, I have 77 terabytes worth of NVMe drives, but only 24 terabytes available once the Ceph pool has been configured. In this configuration, where Proxmox nodes are directly controlling each Ceph OSD, performance is exceptionally good, even over their shared 20 gigabit network connection. For our use case here, that is storing VM disks for Proxmox on OSDs hosted by Proxmox, it's an ideal situation, as it's natively configured with the Proxmox cluster setup. It makes the Ceph pool natively accessible by any node in the cluster, and doesn't require any additional hardware to make it all work. With the Ceph pool created, it should automatically be accessible from each of your nodes, and if it does show up, you're basically ready to roll, at least when it comes to creating and running virtual machines in a cluster with a shared Ceph storage pool. One thing I'd like to note at this stage, and I'm not sure if it's the Epyc 4565P CPUs or the Gen 5 Ceph storage, but VM creation is fast, and I mean really fast. Normally, on a single Proxmox server, you'll walk through the VM creation wizard and then wait anywhere from 20 to 30 seconds while Proxmox sets everything up in the background with the configuration file and the disk image. On this system, hitting create in the wizard, the VM is ready to turn on basically instantaneously. I've never seen that kind of performance before. If you're watching this video, I'm sure at this point you probably already know how to install a VM, so I won't bore you with the details here. If you are new though, I do have some more basic Proxmox tutorials that I will link down in the video description. I did go ahead and set up 4 VMs on each node, mainly because I wanted to show why you might want to run a Proxmox cluster instead of individual servers in some environments, and to figure out if this solution is right for you. Focusing on small and medium business environments, server downtime can mean complete work stoppages for your business. If you're running services like Active Directory, inventory management or payment processing databases, ticketing or sales systems, even a few minutes of downtime can add up to a tremendous loss in business or productivity. While most services have options for redundancy, and you should use them, Proxmox also offers high availability modes to automatically transfer and keep alive VMs if a node goes offline. Having both clustered VM hosting and storage all in the same system means less overhead for high availability services, and again, less hardware than you might have needed in the past. In a Proxmox cluster with shared and clustered storage, you can live migrate virtual machines with essentially no downtime. Let's say you needed to take a node down for maintenance or upgrades. Simply select the node that you need to shut down, right-click on the VM you want to transfer, and click on Migrate. Then select the node that you want to move the VM to, and click on Migrate again. Since we're on clustered storage, the VM's files technically already exist on the new node, so the migration process only needs to transfer what is stored in active memory over to the new node. The majority of RAM can be copied while the VM is still active. Once it's all copied, the VM pauses momentarily while the last bit of active memory are copied, as well as checking for any bits that might have changed during the transfer. And the VM spins up on the new node as if nothing ever happened. Live migration makes shuffling of VMs to different nodes pretty much seamless, with often less than a second of downtime to move a VM between nodes. But what about moments of unscheduled maintenance? What happens if you lose a node because of hardware issues, network outage, or power outage? High availability is a feature that allows Proxmox to monitor VMs in a cluster, and if it detects that a VM has gone offline, automatically spin it up on another node, again with virtually no downtime. And just to show how well it works, let's set up a VM with high availability, and then I'm going to go pull that node out of the cluster while it's running. First, go to Data Center in the Web GUI, and then HA, or High Availability. I've already got VM number 644 on node 5 monitored for high availability, so let's go ahead and set up number 643. Under Resources, click on the Add button. This will bring you to a list of all of the VMs in your cluster. I'm going to scroll down and select VM number 643. There are settings for max restart and max relocate, which are the maximum number of tries the cluster will attempt to get the VM running on another node. For right now, we're going to leave these at the default setting of 1. Once you're done, click on Add, and that's pretty much it. Your VM will now automatically migrate to a healthy node if the cluster detects it's gone offline. All right, here we are out in the garage by the server rack, and you can see the Microcloud cluster is sitting right here in the center of it. Now, I did go ahead and configure all 4 VMs on MC5 as high availability. And this is definitely not the recommended way to test this. I'm literally going to pull MC5 out of the server cluster while it's running. Now, unlike the live migration that I demoed a little bit earlier, this will involve some downtime. The server nodes won't have the ability to transfer the live memory from one server to another, so they will start up the VM on a new node and have to reboot it. Now, the whole process takes about 2 minutes in its current configuration, mainly because the nodes need to be sure that if a node goes offline, it's actually offline and not just a network hiccup. You don't want another node to spin up the same virtual machine with the same IP address and accessing the same databases or whatever other services you're trying to run, as that will create way more problems than it's trying to solve. But as you can see on the screen right here, we have MC5 and it is currently running. We've got the 4 virtual machines that we are going to be transferring without any intervention at all to the other nodes as soon as this one goes offline. So, without further ado, 3, 2, 1, and node 5 is now offline. So I'm going to go up here to Data Center. I'm going to click on High Availability, and right here is MC5. What's going to happen is it's going to miss its next heartbeat. From that moment, the other nodes will wait 60 seconds, then they will establish a new master if a new master needs to be established through a quorum, and then they will start divvying up the processes or the VMs amongst themselves. So there's the missed heartbeat right there. Right now, MC2 is the master, and a quorum has already been established, so the quorum is not going to change. So after 60 seconds, the nodes will determine amongst themselves which node has the least amount of draw on it right now, and it will transfer the VMs in a certain order over there. Now, you can also define certain resources that have to be available on a node. For example, if you have a node that requires graphics capability, you can make sure that that only transfers to a node that also has a graphics card on board. So we're about 20 seconds in so far. There's 30 seconds. There's 60. And we should, on the next heartbeat, start seeing the new VMs pop up. And there they are. Looks like MC1 picked up 2 of them. We've got the Windows one on MC2 and another Ubuntu one on MC3. So give those about 30 seconds or so. Those will be started up and start running as, I mean, obviously something happened. They went fully offline, but they will start up without any intervention at all. And that's kind of the whole point of this process. And there we go. We're all running less than 2 minutes for that entire thing. So here at the bottom, you can see MC5 is completely offline, and more importantly, there's no VMs that are associated with it. That means if, let's say, MC5 was just knocked offline because of a network interruption, it's not going to reestablish connection with the cluster and start its VMs again. Those VMs have now been completely reassigned to new nodes. Now, obviously, if you have a node crash, you probably still want to have a tech take a look at it. But at the very least, this gets the VMs back up and running, and they'll start running through any automated scripts you have set up and hopefully bring your services back online with fairly minimal interruption. So wrapping this all up, the cool thing about servers, networking, PCs, there isn't one correct way to put everything together. There are best practices for securing your data and making sure your services stay running on the servers that you run, but there's also a million ways to achieve the results that you're after. One of the reasons a lot of people decide to run home labs is to tinker with different solutions. And the cool thing about what I showed off with Proxmox today is it doesn't need $40,000 worth of hardware to get started with it. A couple years ago, I built a similar Proxmox high availability cluster running a trio of $300 servers and demoed the exact same high availability configuration. The concepts and settings for this can work whether your budget is $500 or $50,000. So if you've ever wanted to try running clustered storage and virtualization setups, there's no better time to try and get started. Thanks again to Supermicro and Solidigm for lending me some amazing hardware in the Microcloud node server, along with the PS1010 Gen 5 NVMe drives for this project. If you're interested in learning more about the hardware used in this video, I will have links down in the video description. I'll also have written instructions for creating a Proxmox CEPH cluster available down below. On your way down there, make sure to drop this video a like and subscribe to Craft Computing if you haven't done so already. Follow me on the social medias at Craft Computing for daily shenanigans like this. And if you like the content you see on this channel and want to help support me in what I do, consider joining the Patreon. Link is also down in the video description. You can also help support the channel by buying some of my merch. All of my merch was designed and is made right here in-house by me. We've got pint glasses, whiskey stones, rocks glasses, stone coasters, bottle openers, a whole bunch of stuff that is actually cut on my laser right next to my server rack. So if you want some truly unique and awesome quality merch, craftcomputing.store. And that's going to do for me in this one. Thank you all so much for watching, and as always, I will see you in the next video. Cheers, everyone. Beer for today is an annual tradition. It is a collaboration between Fort George Brewing, Mirage Beer, and Sunriver Brewing this year. This is the three-way IPA. They come out with this every single year, and it's different every single year. It's usually a collaboration with a couple of other Oregon breweries. Sometimes they expand beyond that, but always a fun one to get a hold of. I love that even though you're cooperating and being on the desk, you are still just barely off camera. Yeah. Just enough to let people know you're there. So the Fort George 2025 three-way IPA, 7%. I'm normally a really big fan of this one. I don't think I am this year. There's a couple of things that I'm genuinely not liking about this year's three-way IPA. And this is hard for me because I think there's some really good notes in here. It's just, there's a couple extremes that are pushing me to not really enjoy this one. It's trying to be super, super bright, but it's bright in like a vegetal sense. It's that West Coast IPA that's more celery and grass than it is floral or citrusy. And so it's got that grassy taste just cranked up to 11 right off the bat. But then it's also super, super dry throughout the entire palate. While I can see what they were kind of going for here, that is like a bright, summery IPA that's nice and refreshing, this one makes me more thirsty. It is so dry. It's gone from crisp to grating, if I am explaining that properly. Yeah, it's like celery and crabgrass cranked up to 11 right off the bat. And then it kind of settles into this dank but still very vegetal, like mid-thick section. But then as soon as you like swallow the drink, it completely sucks all of the moisture out of your mouth and leaves you with this overly bitter flavor. I think this is just a miss for me. I think it's still probably a fine beer. It's just a couple of flavors that can be a little grating on me. They're here in their strongest presence that I've ever had them in an IPA. Not one I'd try again. But if those flavors that I described are ones that are in your wheelhouse, you're probably going to love this one. So, different people have different preferences for flavor, and that's totally okay. I hope you enjoy this one. Say goodbye, Rambo. Say goodbye, buddy. Yeah. You're internet famous. Did you know that? Yeah, go bye.